In the past, we developed a vehicle that was capable of autonomously controlling itself in 3 degrees of freedom. This includes roll, pitch, and yaw. We used 4 thrusters to do this. Using this older vehicle as a test bench, we could get used to the types of systems and control algorithms that we will be working with. Now, current hardware and software development on the lunar line is in creating the next generation of an Earth-based simulator for our spacecraft. What you see in this video is initial test of a proof-of-concept vehicle that we have designed. Instead of 4 thrusters we used in the past, this new vehicle has 3 groups of 2 propellers, for a total of 6. The point of this is to try and simulate the 3 thrusters on our spacecraft. The contra-rotating design allows us to cancel out the unwanted reaction torque on the body due to the aerodynamic drag on the propeller. And since our spacecraft thrusters will only be providing thrusts in one direction, this is a very important aspect of this next-gen simulator. So this test is showing that we can control yaw, pitch, and roll in the lab environment. After we tune the controller and fly the intermediate version of the Earth-based simulator outside of the lab environment, the next step is to build a scaled-up version of this same design. The idea is to be able to test some of the flight hardware and software that will eventually be used on the actual lunar line here on the Earth before sending it into space. This includes the inertial navigation system, flight computer, and the GNC algorithms that we will develop. Now, this requires the capability of lifting and controlling a payload of several kilograms. In the past, we used electric ducted fans. The issue with this propulsion system is that it requires a large amount of electrical power, and this translates into large amounts of mass taken away from our payload budget. So what we plan to do in the future on this next version is to use a jet turbine to take out 5/6 of the vehicle's mass, and this will simulate the lunar environment. While we use a similar contra-rotating propeller design like the proof-of-concept vehicle for the control system. What you see here is the first test of our jet turbine. We built this simple test stand to get acclimated with the systems, and our next step is to build another test stand that we will use to perform a system identification for the turbine. The point of this is to know precisely how much thrust we will receive for a certain input.